Hi, boys and girls. Welcome to sixth grade Earth Science. And today's standard that we are going to review is design models representing motions within the Sun, Earth, Moon system to explain phenomenon observed from the Earth's surface. That can include positions of celestial bodies, day and year, moon phases, solar and lunar eclipses, and tides. So in today's lesson, we're going to focus solely on how the sun affects the earth with day and night and seasons, and then also how the moon, how we see it from the earth, and how the moon affects the earth with tides. So you have observed that each day the sun appears to rise in the east, which at a high point, which reaches its highest point at noon and sets in the west. This apparent motion of the sun is due to Earth rotating on its axis. As the Earth rotates, half of it always faces the sun. Locations on Earth's surface facing the sun experience daylight, while locations facing away from the sun experience darkness. Every location goes through a cycle of daylight and darkness in 24 hours. We call this cycle day. This is something you are very familiar with as you've experienced days and nights your entire life. I have this little video here that I'm going to play. It does a really great job of animating and illustrating to see that the Earth is spinning. And on the left side here, we have the sun. And on the right side here, we have the darkness. You can see the different land areas here. This is the tip of Africa, experiencing daylight. We're coming into the Middle East. They're going to experience daylight next. All right, I think that video is super relaxing. I do really like it. Oh, play it again. All right, so let's discuss the Earth seasons. The Earth revolves around the sun, following a path called an orbit. It takes about 365 and 1/4 day or a year for the Earth to complete its orbit. Earth's axis isn't perpendicular or straight up and down in relation to its orbit. It's actually tilted. This tilt, along with Earth's changing position in its orbit, causes in the first the northern hemisphere and then the southern hemisphere to be pointed toward the sun, resulting in our seasonal changes. So here's a picture to illustrate what I just said. We're going to start here with the North Pole tilted away from the sun, and it's at a tilt, so it's not straight up and down. This white line represents the equator, and you'll see that this part here that's lit up is from the sun, and the northern hemisphere is receiving less direct rays of light from the sun and energy and heat, resulting in our winter. And as you know, our temperatures drop and it is colder, and we have shorter days. The sun sets earlier in the night because of that. So we're tilted away, and then the southern hemisphere is always experiencing the opposite seasons than what we are experiencing in the northern hemisphere. So the Earth orbits around the sun, and over here, our season after winter is spring. And yes, the Earth is tilted still, but the tilt isn't toward the sun or away from the sun, it's just tilted. This white line, again, is the equator. And what we experience here in the spring is more even daylight and nighttime hours. You have closer to 12 hours of daylight and 12 hours of nighttime. And we call that the vernal equinox. So that happens on about March 21st every year. The first day of spring is what we refer to it as. The Earth will continue its orbit. And in this picture here, the North Pole is tilted toward the sun, and that is our summer in the Northern Hemisphere. We're getting much more direct rays. We're having longer daytime hours, much higher temperatures, and that's because of this tilt being tilted toward the sun. We're going to rotate another 3 months to here, and the season for the Northern Hemisphere after summer is fall. And this is like the spring. The tilt isn't toward the sun or away from the sun. The Earth is just simply tilted. And we call this the autumnal equinox. So you have about 12 hours of daytime and 12 hours of nighttime, and pretty mild temperatures. And then we will continue our orbit, and we're going to come right back to here, where again we will experience the season of winter. And we'll have our shortest days, and we call that the winter solstice. So we have the winter solstice and the summer solstice, and then we have the vernal equinox and the autumnal equinox. And that winter solstice takes place on December 21st each year. All right, so the next object we're going to talk about is the moon. The moon is the brightest object in the night sky and Earth's nearest neighbor in space. Together, Earth and the moon are part of the sun's planetary system. Pulled by the sun's gravity, the Earth-Moon system revolves or travels in a closed path around the sun. Pulled by the Earth's gravity, the moon revolves around Earth in an ellipse-shaped orbit. So ellipse means it's not a circle, it's a little more oval-shaped. Like Earth, the moon rotates on its axis. However, the moon takes nearly 23.7 days to complete one rotation. Even though the moon rotates, the same side of the moon always faces the Earth. This is because the moon orbits Earth in 27.3 days, exactly the same amount of time it takes for it to rotate on its axis. That's why we only see one side of it. So the moon goes through phases, and I'm sure you've observed in the night sky all the moon phases, and you might want to know, why do we see the moon? Why don't we always see a full moon every single night? And that's because it's revolving around the Earth, and the moon changes its position and how the sunlight can illuminate the moon. Although the moon shines brightly at night, it does not give off its own light. We see the moon from Earth because sunlight is reflected off of its surface. As the moon orbits Earth, its position in the sky changes. This produces different shapes or phases of the moon we see each month. The phase of the moon, as seen from Earth, will be demonstrated using a lunar phase simulator. So let's check out the simulator. So right here is our sunlight, and this is going to be our moon phases. So I don't know why I don't have my Earth on here. Oh, it's still loading. That's fine. What we're going to see in just a minute is the Earth should pop up. Okay, so here is our lunar phase simulator, and this is Earth. This is us on the Earth. I can put us in daytime, but I'm going to move us over here to nighttime, because that is how we see the moon, is when it's our nighttime. This is the moon. This is the sun. And this is where you're going to see the moon phases. So I'm going to move the moon around, and when we're right here where we can't see the moon because the backside is getting all the sunlight, this is what we call the new moon phase. And right here, it's going to tell you what phase we're experiencing. So I'm going to rotate the moon. Now see, remember where we're at right here. So this is how we see the moon. We're only seeing this teeny tiny corner piece right here light up on the right side, and that's called a waxing crescent. Okay, I'm going to keep moving, and you can see that this crescent's getting bigger and bigger, and right here, this little space that's white on this side is starting to light up more, and we can see more of it. And then we're going to reach this next phase, which is called the first quarter, and that's where this one quarter, if it's a circle and we were break it into 4 equal pieces, it would be quarters. So we're seeing this quarter of the moon being lit up right here. And then as we keep moving, this is called a waxing gibbous. And remember, we're right here. This is us. And now we can see more of the moon. And then I'm going to move it all the way over here. And we have what's called the full moon, because we can see all of this nice and bright. And then I'm going to continue to bring it on around to our waning gibbous. So now it's big and white, but it's on the left side here. We're going to bring it all the way up to third quarter. So this is the last section of the moon. The last quarter lit up. Now we have our waning crescent. Again, we got this crescent shape here. And we're going to end up back to our new moon phase. So this is a pretty cool simulator. I suggest you check it out. It's pretty handy. You can just type in lunar phase simulator and do a search for it, and it'll pop up. It'll be one of your first choices. All right, let's go back to our slides. So now we're going to talk about eclipses, solar and lunar eclipses. On the left side here, I have a poster of solar eclipse, and this is where the moon gets in the way between the Earth and the sun. And you might be thinking, well, that happens all the time because we have a new moon every month. And you're right, that does happen. We do have a new moon, but the moon and the earth and the sun don't always line up. So this is when they have to line up perfectly. And it has to be from where you're standing on the earth that you see it lined up. So when I show you the eclipse simulator, you'll better understand that. So all bodies in the solar system produce shadows in space. An eclipse occurs when one object passes through the shadow of another. A solar eclipse or a lunar eclipse occurs when Earth, the sun, and the moon line up. So a solar eclipse occurs when the Earth passes through the new moon's shadow. So the new moon gets in front of the sun, but it casts a shadow on the Earth. During a total solar eclipse, the moon appears to completely cover the sun. The sun darkens, and only the sun's outer atmosphere is visible. It can be seen glowing as a bright circle around the moon. A partial solar eclipse occurs when the Earth passes through part of the moon's shadow. And so that would only have like part of the sun blocked out and not the whole sun blocked out. A lunar eclipse occurs when the full moon passes through Earth's shadow. When Earth passes between the sun and the moon, it blocks the sun's light. However, Earth's atmosphere bends certain colors of light, especially red. This makes the eclipsed moon look like a dim red circle. So I'm going to show you this eclipse simulator next. And I'm also going to go ahead and let Earth rotate here. And you can see this is the sun, this is the moon, here is Earth. And you can see this white line is showing you the path that the moon is on. And you'll notice this is the shadow of the moon that is being cast from the sun to the moon. There's its shadow. Up here, you're going to see the eclipse, and you're going to see this tiny area of land that would experience it. So only a teeny tiny area even sees that eclipse if it's lined up perfectly. So the moon's going to continue its rotation around the Earth. And now you're going to next see the lunar eclipse take place. Takes just a minute. This is a pretty cool simulator. I suggest you check it out. It's kind of slowed down here for us. It's from the earthspacelab.com website. And now the Earth is going to get in, block the moon, the Earth's shadow. You're going to see that up here. Pretty cool. I like both of those simulator websites. All right, let's go back to our PowerPoint. Now let's discuss the tides. So not being from the coast, I had to learn a thing or two about tides other than having seen it in a textbook as a child. I've never really experienced what a tide was. So tides occur once or twice each day when ocean waters rise and fall at beaches all around the world. This repeated rise and fall in the level of the ocean is called the tide. Tides are caused by the pull of gravity of the sun and the moon on Earth's waters. Since the moon is closer to the Earth than the sun, it has a greater effect on tides than the sun does. So I'm from the Midwest, not near an ocean, and so we didn't experience tides. So this is something that I had to kind of learn and see for myself. In this picture here, you'll see we have the moon, and it's creating this bulge. Represents the bulge for the water, and this would be a high tide. This would also be a high tide. And then on the sides, from how, because remember the Earth is spinning here, this creates our low tides. So the pull of the moon combines with Earth's rotation to produce traveling bulges of water. The moon's pull on the oceans is strongest on the side of the Earth facing the moon. This causes the Earth's shape to become slightly oval. Solid parts of the Earth change very little, but the ocean bulges out on the side of the Earth nearest the moon and on the side furthest from the moon. As the Earth rotates, it pulls these bulges along. The bulges of water on either side of Earth are called high tides. Low water levels between high tides are called low tides. Most coastal areas have one or two low tides and one or two high tides occur at regular times, which can be predicted. So your local meteorologist always include in their report every day for the weather is what time to expect high tide and low tide. And that's super important for our boating industry because we live on the coast. Where I'm from in the Midwest, that is not a part of the daily meteorologist report. So here is a picture, and it shows you the tidal bulge due to gravity, just similar to the last picture. And you can see the low tides occur here. The highest tides occur on the side facing the moon, and then opposite of that. And you have to remember the Earth is also spinning, and that is causing those waters to move and to create those bulges from the gravitational pull of the moon. And that is it for this lesson and how the Earth Sun Moon relationship affects objects on the Earth and how we see things from the Earth and our seasons and why our temperatures change and why we have different seasons and even why our days, our length of days and nights change over time.